Grab project, gravity assisted pulse motor update. What we're going to do is try to test manually what sort of results we can get with the PMA. So at this point, it's connected up to a 65 watt auto light bulb headlamp, and it's just we're just going out of two of the legs, and there's so much back EMF. Because this is AC output, and there's so much back EMF that it doesn't even generate over 2 volts AC. And we'll show you that's it. So we get nothing. There's a lot of resistance, hardly any RPM, and I measured it, and it doesn't generate. It generates like 1.6 volts AC because there's so much braking. All the energy is going into producing heat at the stator coils. So now we'll hook up the bridge rectifier, capacitor dump bank. Where is it? Oh yeah, the pulse width modulator circuit, and we'll see if we can light the. I'm calling it a 50 watt bulb. Yeah. So this is the approximate voltage results. We have the three-phased bridge rectifier charging up, the capacitor bank, and yeah. All right, so about 60 volts, and you can see the RPM difference. Yeah, it's a higher RPM. Again, that's because it's experiencing very little back EMF because it's basically all you're doing is charging large capacitors, so essentially there's really no load on the device. So now we'll try hooking up the pulse width modulator. Okay, we've attached the hand crank just to get some idea of what kind of RPM and what to expect at the output. Let's see. I haven't completed the installation of the transmission, so we won't be able to do the falling weight test. But let's see. So at about 60 RPM, we're getting about 24 volt DC out of it, and you can see it's just barely illuminating the 50 watt bulb. So. And that's using the pulse width modulator. Without the pulse width modulator, there's so much back EMF that we can barely, achieve 2 volts at the output. So that'll give us, what we need to do. We have to increase the RPM, and we'll try to get the pendulums working. Because right now, this pulse motor configuration, there's no way it's going to generate enough force to get this up to, operating RPM. So, thanks for watching. Enjoy the day. This is just, to document my progress. And so there we got 3-phased alternator going at about 60 RPM. We're getting about 24 volts at the output DC. We're using the pulse width modulator. And we're barely achieving enough current to illuminate the 50 watt bulb. So, at some point I'll hook up an amp meter and we'll get an actual amp reading. But I'm expecting or suspecting it's not going to be that much. So, we'll post results when available. Thanks for watching. Enjoy the day. Cheers. So this was just to illustrate the, this is about 35 ohm stator. Between the legs, and the higher the resistance, the more back EMF, and the more back EMF, the more braking effect, the harder it is to crank. So that's why we added the pulse width modulator and capacitor circuit. In the future, we'll be working on a capacitor dump circuit where you're just charging the large cap bank, disconnecting it, discharging the large cap bank, and then reconnecting it. And we can have 2 cap banks charging and discharging simultaneously, which will probably greatly reduce the effect of the back EMF of the high resistance at the stator. So, thanks for watching. Cheers. And depending upon how you have the pulse width modulator adjusted, it affects the voltage. It requires a higher RPM, but we're getting, a higher output at the bulb, but we're getting a decrease. Well, depends upon the output. But, yeah, it makes a big difference. So definitely higher RPM when using the pulse width modulator, but it's easier to turn, that sort of thing. So post results when available. Thanks.